Mina Farmanbar is an associate professor at the Computer Science and Electrical Engineering department at the University of Stavanger, and also an advisor at Lærdal Medical at the moment. And she is recognized as one of Norway's top 100 women in AI. And among many different roles, she also have been working in the program committee in NORA for the NORA annual conference. The title for Mina today is Detecting Dementia with Language and AI, a new frontier in early diagnosis. Please.
Yes, thank you for the introduction. Here I will talk about how advances in AI and language technology are helping us detecting dementia, particularly Alzheimer's disease, earlier and, let's say, more accurately than ever before. So Alzheimer's disease is a neurodegenerative disease coming with impaired ability to remember, thinking and making decision. So an estimated around 7.2 million people in the US will be affected and reported in 2025. Yes, Alzheimer's disease is primarily known for its cognitive decline, but beyond cognitive decline, it comes with different non-motor and motor symptoms, including language problems, depression, sleep disturbance, and in the later stage when the disease is progressed due to the widespread damage in the brain. We have slowness of movement and postural instability. So the early recognition of cognitive decline present a clinical challenge and is crucial for timely intervention and improving the quality life of patients and slowing down the progression. Interestingly, speech and language is one of the early indicators of cognitive decline. So people struggle finding words, repetitive phrases, or lose coherence, despite traditional diagnostic tools like MRI scans are still quite expensive and may not be easily accessible in low resource settings. So here it's where the AI-based language analysis comes in by analyzing how people speak rather than what they said, right? So as a window into the brain health. Recent advancement in natural language processing and speech analysis have significantly enhanced the early detection of Alzheimer's disease. So based on our systematic literature review, we found out simulation analysis have shown that AI-based speech screening could improve Alzheimer's detection and reduce the need for MRI scans by around 35%. Different approaches are employed in AD analysis. One is what is said, so the content and the structure of language, known as linguistic features like speech richness, content quality, repetition, grammar, and so on. So these features mainly reflect linguistic ability and cognitive organization. There is another category, how it is said. The acoustic and prosodic aspects of speech, also known as paralinguistic features, which includes voice tone, pitch, rhythm, the speed of the speech, the pause patterns, and so on. So these features reflect neurological control of speech production and emotional modulation. Another category is why it is said that way. So the emotional and cognitive states conveyed through language use. It is also known as psycholinguistic features. So these features indicate emotional health, mood, and thought patterns. So we mainly focus on the first category, what is said, mainly on linguistic features. So we try different approaches, different data sets, and so on. We published a couple of papers with my PhD student, and based on what we have done and what the literature is shown, we found a gap. So most prior research has framed AD detection as a binary classification, limiting the ability to identify mild cognitive impairment, or MCI. So we know that cognitive impairment is a continuum. So there is one category in between. So we have healthy control, we have individuals with AD, and somewhere in between is called MCI, which is quite difficult to be detected. Another gap is that most studies rely on single language data sets, mainly in English, which restricts the cross-language generalizability. So in this work, we introduce a novel multilingual conversational data set by unifying 16 different data sets spanning from English, Spanish, and Spanish, Chinese, and Greek. So we have done lots of pre-processing to unify all these data sets and make a kind of single multilingual data set. We cover two modalities, text and audio, and with different tasks. We have a picture description task, which is a picture given to a patient, and patient is asked to describe what they see in the picture. And we have fluency task, story recall, and so on, right? So this multilingual data set is used is used to increase data diversity. Yes, we try different approaches, different settings on monolingual, combined multilingual, and combined translated. So we have seen that Chinese shows improvement with combined multilingual, while Greek experiences a decline in performance. So we tried another work. We evaluated the effectiveness of LLMs. We wanted to see if we don't have enough data to train our model, how LLMs can help us, right? So we tried different models, 3 general purpose and 3 medically tuned LLMs with different prompt components, and we found out, yes, if we design the prompt in a very thoughtful way given to the LLM, so the model is able to perform tasks like detecting cognitive decline. Then last one, we try to analyze interpretable linguistic features. So we use a data set that contains both Chinese and English speech data sets. So we applied, we used LFEN and LFTK toolkits, both Python-based toolkits, to extract the linguistic features from both English and Chinese. We applied ANOVA and followed by HSD test to find out if there is any differences within the linguistic features from different languages. So English showed greater future variance than Chinese, and we found out most MCI people tend to use fewer pronoun and use longer disfluent sentences. Yes, so the key takeaway here and the conclusion is that yes, AI-based language analysis can be used as a tool to help detecting dementia in early stage. But of course, that would be nice if we combine it with other modalities in order to increase the performance. So it could be combined with emotional expression. It could be combined with MRI images or other modalities as well. Yes, thank you so much. Mm-hmm.
There's room for a question. Yeah.
Thank you, Mina. I'm very ignorant in the field. I was just curious. So you have mentioned some data sets with this discussions.
Yeah.
When you use these phrases, do you use also temporal correlation there? Like if it's a long discussion, how the discussion evolves during the discussion time, and normally how long are these discussions? They are like just questions, or there is like a 10-minute discussion with the subject?
Depends. For example, in picture description task, no, they are free to speak as much as they can. But in fluency, like in verbal tasks, or semantic fluency tasks, they are asked to, for example, name as much like animals or foods as much as they can in, let's say, in 1 minute, right? So yeah, different tasks are.
Time is taken as a variable at the end or not?
No, not in our analysis. No.
Okay.
Yep.
Thank you.
Okay, one more question, short one.
So thank you for the great talk. You mentioned that AI really has its greatest potential in low resource settings. But then again, do you think that will happen, or will AI actually mostly benefit the high resource people and settings?
Yeah, that's true. Maybe yes. Based on our experiments, we have seen that those data sets which are not in English, they still suffer from from being detected using AI. And that's why we try to combine and unify this data set and make it available for others to experiment more. Yeah.
Yes, thank you again, Mina.